Good afternoon, student. Last class we discussed about the modulations. What is modulations? Types of modulations, need for modulations, and modulation factor, expression for the modulation factor, and significance of the modulation factor. These are discussed about the earlier classes. The important is modulations. It is conversions to low frequency signals to the high frequency signals and functions of the carrier wave to carry the audio or video of the radio waves to travel to the transmitting antenna to the receiving antenna, and the equations of the carrier wave we represented the modes of the modulations, that is amplitude modulation, frequency modulations, phase modulations. So we have to know the carrier wave equations. Small ec is equal to capital EC cos omega ct plus theta, where small ec is a spontaneous amplitude, capital EC is the frequency, and theta is the phase difference. Now modes of the propagations: amplitude modulations, frequency modulations, and phase modulations. And what is amplitude modulations? Amplitude is varied in accordance with the frequency and phase becomes constant. And what is the frequency modulations? The frequency is varied in accordance with the amplitude and phase becomes constant, and the phase modulation is in accordance with the constant of the frequency and amplitude modulations. These are the types of the modulations. And one need for the modulations: there are the 5 needs for the modulations: and practical antenna length, mixing up of the signal, effective power radiated by the ionosphere, and the to transfer the signal from one place to the another place. So we have discussed about the need for the modulations. And the last class we discussed about the modulation factor. It is the ratio of the before modulation to the after modulation, that is the carrier frequency to the unmodulated wave frequency, that is known as the modulation factor. And modulation factor equations to depends upon the values, that is what is the modulation factor depends upon the values, that is 0 and 1. Modulation factors equations to defined as the V maximum minus V minimum divided by V maximum plus V minimum, that is the equations of the modulation factor. Now discuss about the significance of the modulation factor also, that is M is greater than 1. The modulation factor of the amplitude is maximum to travel to the signals, that is the mixing up of the signals, and M is equal to 1, the 100% modulations was going on, and the modulation factor is 0, there is a over modulations. Now we have discussed about the significance of the modulation factor. Now today we discuss about the block diagram of amplitude modulation transmitter. We have to know the amplitude modulations and where it travel to the transmitter antenna, how to signals will be applied to the modulation factor, and how to convert the modulations to two signals to conversions of the amplification process, how to getting the transmitting antenna to the audio or video signal. We have to know that block diagram of the communication system. First the information source will be there, and information source will getting to the message signal. The message signal is goes to the transmitter. The transmitter works on the signals will be captured. The signals comes to the transmitter, and transmitter signals which emits the signal, radio or audio signal. When I apply the signals to the transmitter signals will be emitted on the signals. It goes to the channels. Channels will be help of the transmitter signals to produce or jump or receiver to the signal of the messages. But the channel will works on the depends upon noise. Noise means it is a mixing up of the signals. In the case of the block diagram of AM transmitter, we have to define modulator. In the case of works on the block diagram of communication system, it works on the channel because there is a two inputs, that is a transmitter signals and noise, and only one output, that is known as receiver signal. The receiver signal capture the signals of the noise and the transmitting signals to getting the amplification process to goes to the informations. To know the informations, to get the antenna, we have to see the videos or audios of the radio waves of the communication system. Then the basis how to works on the amplitude modulations in the transmitter. In the case of amplitude modulations, there is a different ways to travel to the antenna. We have to see the block diagram of the transmitter. This is the block diagram of the transmitter. First of all, what is the microphone? The microphone means which is a conversion process, that is a conversions of the signals from the audio signals to the video signals or audio signals of the radio waves to convert to the loudspeaker, to conversion process of the microphone which is used the only audio signals. The microphone, the travel to the first of all audio signal. This is the first you have to know the what is the communication system in the process of amplitude modulations. The microphone, audio free amplifier, modulator and RF amplifier and oscillator, then antenna. These are instrument are used for the block diagram of AM transmitter. What is the first case? The first case is microphone which is the audio signals to transfer to the modulator. This is the microphone of the audio signal. It goes to the audio free amplifier. Audio signals are the weak signal, so we have to amplification process. Amplification means increasing the strength of the weak signal. So microphone audio signal becomes weak, so increase the strength of the weak signal to apply to the pre-amplifier. That is free amplifier we apply to the audio signals of the low frequency signals, then we get the amplified the audio signal, then it goes to the modulator means which is conversion of the low frequency signals to the high frequency signal or superimpositions of the intensity of the signal from the output, that is the amplitude, frequency and phase. So we have to know the amplifier of the audio signal which comes to the modulator. Then modulator, these have the works on the channel. We have to say that communication system already same as it is works on the modulator. Why it is works on the modulator is equal to the channel? Because the RF carrier signals, that is the carrier signals, oscillator which is also combined to the modulator. The input is 2 input and only 1 output. So we have to take the oscillators of the signal which comes to the modulator and amplified of the signals which come to the modulator. The modulator which works on the modulation process, and the modulations we getting the output is modulated radio frequency signal. Modulator it works which is output to getting the modulator radio frequency signal, but the radio frequency signal is weak, so RF is amplification process becomes weaker, is increase the amplifications works. So we getting the RF amplifier of the material, we can use the output, then it goes to the high amplitude RF signals to the transmitter antenna. This is the process of the block diagram of amplitude modulation transmitter. We have to know the two methods we have discussed about. The first goes to the microphone, audio amplifier, then modulator, and the second one is oscillator and modulator. And these first part and second part which combine to the getting the modulated radio frequency signals, then output becomes amplification process, then the high frequency signals of the radio frequency signal getting to the antenna. This is the block diagram of the amplitude modulations of the transmitter. See, another one diagram is there. This is also a block diagram of the AM transmitter. We have to see that same as it is. Already we have to know the one diagram. Same, there is no difference of the amplitude modulation of the radio frequency, that is a transmitter. See, RF sections: crystal oscillator, buffer amplifier, RF power amplifier, modulator. Then microphone, AF amplifier, AF power amplifier, then modulator. We have to see what we have to know that, then same as it is: microphone, audio free amplifier, modulator. This is the one process. Same, this is the one process: crystal oscillator, buffer amplifier, RF power amplifier. This is the one process. And second one, oscillator. What is oscillator? Second one, microphone, AF amplifier, AF power amplifier. This is the one of the common. Then these two block we have to indicate same as it is two processor, that is known as the AM transmitter. Signals will getting the output, where then we have to see that we have then what is the crystal oscillator? First, crystal oscillator means the signals of the carrier frequency. That means the carrier wave is supplied. The carrier wave is supplied to the crystal oscillator at the carrier frequency. It is followed by the tuned buffer amplifier and the RF power amplifier. ಇದೇನಾಗ್ತದೆ ಅಂದ್ರೆ ಒಂದು ಕ್ರಿಸ್ಟಲ್ ಆಸಿಲೇಟರ್ ಆಫ್ ದ ಕ್ರಿಸ್ಟಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ which getting the buffer adandre combine agdiradi. The crystal frequency is a maximum frequency oscillations or process which goes on the buffer amplification, and buffer amplifier which goes to the RF power amplifier, radio frequency, which is the amplification process is high. So which is sections is known as RF sections have defined as that is a maximum power or maximum amplitude which is a travel to the modulator. Then the second one, microphone, AF amplifier and AF power amplifier, which means the source of the audio frequency signal is a microphone. The audio signal is amplified and a low level audio amplifier, and finally by a power amplifier. It is then combined with a carrier, produce a modulated carrier wave, to produce a modulated carrier wave which is ultimately radiated out in the free space by transmitting antenna. This is the process of the block diagram of the amplitude modulation transmitter. How to define in the case of waveform? How to define? See, what is the waveform of the AM transmitter? See the AM transmitter. This is the first one block is there. You have to see that first one block is there na. So this block have defined, this is the first block has defined the first case, carrier wave. Carrier wave means they have to see the buffer amplifier, RF frequency amplifier, that is the first. We have to travel the waveform, this carrier waveform. And second one, which goes to the output, the RF amplifier, the RF sections will goes to the output, the amplification process of the waveform, we have to see that. And the second is the modulator. It means the modulator process is going on. Then the third one, you have to define the radio frequency generator, that is known as oscillator. This is the section is oscillator. The oscillator wave formations, these is wave formations, it comes to the modulator, and this carrier wave of the RF sections of the waveform come to the modulator. The modulator output becomes these wave travel to the, in the case of modulation, signals. Then the finally radio frequency power amplifier, RF sections of the power amplifier, the signals is weak, so increase the strength of signals to get the output becomes the modulated waveforms to the maximum amplitude. Then M is equal to 1, the 100% modulation process is produced in the output waveform. This is the waveform of the block diagram. See, AM transmitter And first one, input signal, that is informations of the audio signals of the microphone, that is the input signals travel to the second one, buffer amplification process, and buffer amplification process and the RF output amplifier which combine to the input signals to goes to the modulator. And the next one, the power amplifier and the oscillator which is combined to the modulator. Then the modulator output goes to the radio frequency signals, the radio frequency of the power amplifier which getting the transmitting antenna. This is the process of the block diagram of amplitude modulation transmitter. Simply we discuss about the block diagram of AM transmitter is the carrier wave is supplied by a crystal oscillator at the carrier frequency. It is followed by the tuned buffer amplifier and a radio frequency output amplifier. The source of audio frequency signal of a microphone, the audio signal is amplified by a low level audio amplifier, and finally by the power amplifier. It is then combined by the carrier to produce the modulated carrier wave, which is ultimately radiated out and the free space by the transmitter antenna. This is the process of the block diagram of amplitude modulation transmitter. We have to see in the picture to getting the 5 marks or 2 marks block diagram of amplitude modulation transmitter. And the next we have discussed about very important the frequency spectrum or amplitude modulations. That is the frequency spectrum of amplitude modulation, frequency spectrum of frequency modulations, and expression for the amplitude modulations, and the significance of the amplitude modulations and frequency modulations. Okay, thank you.